In this video, we're going to talk about how to factor a polynomial by grouping. So these are going to be like problems in 13.1, number 59, number 61, number 63, 67, and 69. Start off with x to the third plus 9x squared plus 5x plus 45. We're going to group the first two terms with the last two terms. I'm going to make sure that they're separated by a plus sign, not a minus sign. So keep that negative sign with the third term if it was a negative coefficient. Now I'm going to factor out the GCF from the first two terms. And I'm going to factor out the GCF from the last two terms. And we hope that they leave a greatest common factor of a binomial here. And we write the other parts as the other factor. Remember, we talked about how you can double distribute, how you can double distribute, but we can also distribute the binomial over the second set of parentheses, which is what we did here. We just undid that. So let's go ahead and look at 3x plus 9 plus xy plus 3y. Greatest common factor in the first pair is 3. Greatest common factor in the second pair is y. Our greatest common factor is x plus 3 and leaves me with 3 plus y, or you can rewrite it as y plus 3 if you like. Right? Now let's look at this one. 10x to the third minus 15x squared plus 8x minus 12. Greatest common factor here is 5x squared, which leaves me with 2x minus 3, plus the greatest common factor there is 4, which leaves me with 2x minus 3. 2x minus 3 is my GCF, which leaves me with 5x squared plus 4. Now I have 2y minus 18 plus xy minus 9x. Greatest common factor here is 2 times y minus 9 plus x times y minus 9. Y minus 9 is my GCF. 2 plus x is my other factor. Again, that's the same thing as x plus 2, so use your commutative property if you would like to write that with the variable part first. Last problem for this section. 3x to the third plus x squared plus 27x plus 9. Greatest common factor is x squared, which leaves me with 3x plus 1. Greatest common factor here is 9, which leaves me with 3x plus 1. 3x plus 1 is my GCF, and my other factor is x squared plus 9. The remaining factor is sometimes going to factor further. So don't think that just because we pulled out the GCF and then stopped, that that's always when you stop factoring. But that is just all we wanted to do to learn the technique this time, was to have pulling out the GCF be the only step involved here. So next time we're going to come back and talk about some problems from 3.2 where we're going to start factoring trinomials that have a leading coefficient of 1. Come back and we'll talk about those next time.